Today we are going to integrate this expression 1 over 1 plus sine 2 theta with respect to theta, and we can see that there are two terms in the denominator, so we will rationalize. So we will multiply this expression with 1 minus sine 2 theta, and we'll also divide it by the same expression. So this will become 1 over 1 plus sine 2 theta into 1 minus sine 2 theta over 1 minus sine 2 theta. So in the numerator it will become 1 minus sine 2 theta, and in the denominator we have a plus b into a minus b form, so that will be equal to a square minus b square, so 1 squared minus sine 2 theta squared. So this will be equal to 1 minus sine 2 theta over 1 minus sine square 2 theta, and 1 minus sine square 2 theta can be written as cos square 2 theta, because 1 minus sine square theta is equal to cos square theta. Here we have 2 theta, that doesn't make a difference. There's an angle, and we are taking sine square of it, so it will make no difference. So we can write this as cos square 2 theta. So this will become 1 minus sine 2 theta over cos square 2 theta. So now we can break this fraction into two parts. We can write this as 1 over cos square 2 theta minus sine 2 theta over cos square 2 theta. So we'll apply the linearity property of integration. We can apply integration on both of these terms separately. So we'll get 1 over cos square 2 theta, and we are integrating this with respect to theta, minus the integration of sine 2 theta over cos square 2 theta, and we are also integrating this with respect to theta. So 1 over cos square 2 theta, this is simply secant square 2 theta, because secant is the reciprocal of cos, and we'll get minus the integral of sine 2 theta over cos square 2 theta with respect to theta. So secant square of any angle basically is the derivative of tan theta, so tan theta of that angle. So here we have 2 theta, not theta. So but if this would have been secant square 2 theta into 2, we could just have written that the antiderivative of that expression is tan 2 theta, but here 2 is missing, so we'll divide tan 2 theta by 2, and beside this we'll have minus integration of sine 2 theta over cos square 2 theta. So we need to evaluate this integral sine 2 theta over cos square 2 theta, and in the denominator we can write it as cos 2 theta whole squared. In the numerator we have sine 2 theta, which is equal to 2 sine theta cos theta. We get this identity from using sum to product formula, and in the denominator the identity for cos 2 theta is cos square theta minus sine square theta, and this will be squared as well. So we can use substitution to evaluate this integral. I am calling sine theta as u, and we also need to replace this d theta, so we need to take the derivative of this equation, so it will become du over d theta. We are taking the derivative with respect to theta, so this will become du over d theta is equal to cos theta, and du is equal to cos theta d theta, and we are interested in d theta, so cos theta will be divided on the other side, so d theta is equal to du over cos theta. Now we need to write this whole integral in the form of u. So it will become integral of sine theta is u, so 2 times u. I am writing cos theta as it is for now over cos square theta I'm writing cos square theta as well, minus sine square theta is u square, and this will be whole squared. D theta was du over cos theta. So I kept cos theta because we had d theta as du over cos theta. So cos theta and cos theta cancel out. So what we are left with is 2u du over cos square theta minus u square whole squared. So cos square theta is equal to 1 minus sine square theta. So in the denominator we write cos square theta as 1 minus sine square theta. So 2u du over 1 minus sine square theta minus u square whole squared. So sine square theta is simply u squared. So this will become 2u du over 1 minus u squared whole squared. So the final expression will be 2u du over 1 minus 2u square whole squared. Now I am using substitution again, and I'm calling u square as p because in the numerator we have 2u in our expression. So u square has the derivative 2u, so it's useful to substitute u square and call it something. So I have called it p. So we need to change du in dp as well. So I'm taking the derivative with respect to u, so it will become dp over du is equal to 2u, and dp is equal to 2u du simply by cross multiplication, and I need to replace du. So du will be dp over 2u from here. So our expression will become integration of 2u over, that was 1 minus 2 u squared. So u square is now p, so 1 minus 2 p whole squared, and we had du, which is dp over 2u. So 2u and 2u cancel out, and we are left with 1 over 1 minus 2p whole squared dp. So we now need to integrate this. So this is simple. We can move this the expression in the denominator in the numerator, and the power, the sign of power will be changed. So it will become minus 2, and we know the power rule for integration or antiderivative, that if we have a power, an expression, and its derivative is written right next to it, we can use the power rule. So the derivative of 1 minus 2p is just simply minus 2. So I'll be dividing and multiplying with minus 2. So it will become minus 1 over 2 integration of 1 minus 2p whole raised to power minus 2 into minus 2. So we'll apply the power rule for integration. So we'll be left with minus 1 over 2, 1 minus 2p minus 2 plus 1 over the same number minus 2 plus 1. So this will become minus 1 over 2 times 1 minus 2p raised to power minus 1 over minus 1. So minus and minus cancel out. We are left with 1 over 2 times 1 over 1 minus 2p. So this is the antiderivative of the second term of our result, but this is in terms of p. We need to write this in terms of theta. So firstly we need to write p in the form of u, and p was equal to u square. So this will become 1 over 2 times 1 over 1 minus 2 u squared, and u was equal to sine theta. So this will become 1 over 2 times 1 over 1 minus 2 sine square theta, and our solution was basically tan 2 theta over 2 minus the integration of sine 2 theta over cos square 2 theta. So we have found the integration of sine 2 theta over cos square 2 theta, and we just need to subtract that from tan 2 theta over 2. So the final answer will be tan 2 theta over 2 minus 1 over 2 times 1 over 1 minus 2 sine square theta plus the constant of integration.